Here we find the exponential function p of t equals p naught n raised to the power of t over this capital T. So using this information, we are going to find this exponential function. We are given that doubling time is 6 years. So we can say that this capital T and this equals 6. And since it is doubling time, we see that n equals 2. And initial population is given as 500. That is P naught equals 500. So we now plug in all this information into this exponential model, which gives us P of t, and this equals P naught is 500, n is 2, so I write 2, and this raised to the power of t, we put this lowercase t as it is, divided by this uppercase t is 6. So this is the model. In fact, we can rewrite this as P of t equals 500 times 2 raised to the power of t over 6. So this is the exponential model in this form. We now write the population model in terms of this model equation, that is p of t equals p naught e raised to the power of rt. So let's see how to write down the model in this model. So here we know that the p naught, that is the initial population, is 500, and doubling time is 6 years. And this means when t equal to 6, the population gets double. That is, we can say that p of t equals 2 times of p naught, and this equals 2 times of 500. So it is 1000. So we use this information, that is at t equal to 6, p of t equals 1000. Also p naught equal to 500. We plug this two information into the model to determine the r. So let's do that. I'm going to plug in t equal to 6 into this model. So this gives p of 6, and this equals p naught is 500, e raised to the power of r, and t is 6. So it is r times 6. We know that when t equal to 6, this is basically p of 6. So I can put this as p of 6, and this equals 1000. So I'm going to plug in p of 6 equals 1000 into this equation. So I get 1000 equals 500 times e raised to the power of r times 6 is 6r. Now let's cancel or divide both sides by 500, and this gives, we can cancel this 500. 1000 by 500 is 2. So we get the equation 2 equals e raised to the power of 6r. Now I'm going to apply natural logarithm to both sides. When I do that, I get natural logarithm of 2, and this equals natural logarithm of e raised to the power of 6r. Now we use the properties of natural logarithm, that is this power comes in front and gets multiplied with natural logarithm of e. So therefore we can write down this as natural logarithm of 2, and this equals 6r times natural logarithm of e. Let's recall the value of natural logarithm of e, which equals 1. So I can replace this by 1. So that means I can just remove it, because 6 times 6r times 1 is 6r. So we have this equation. From this, we can solve for r. That is, we divide both sides by 6 to solve for r. And this gives r equals natural logarithm of 2 over 6. We plug this into the calculator. And when we do that, we approximately get in terms of decimals as 0.1155. So R is approximately 0.1155, and this is rounded to 4 decimal places. And this means we can plug this value of R into the model. So therefore, we see that P of t equals, we replace P naught by 500, which is the initial population, e raised to the power of RT, that is 0.1155 times t is 0.1155t. So this is the required model in this exponential form.